Greetings, mathletes, and welcome back. We're going to be taking a look at the second part of our lecture here. We're going to be talking about order of operations today. So, without further ado, we'll go ahead and take a look at this. Now, the order of operations, oftentimes it's called an agreement, but it's actually not an agreement. So let me go ahead and write down these steps here, and then we'll take a look at why the order of operations is what it is. So the order of operations, it's basically it's an order that you can follow that will guarantee that as long as you do all your steps correctly, you'll end up with the correct answer. So it's kind of nice that way. But in any case, when you do this, you start with parentheses, and then you hit your exponents, then you hit multiplication, and you actually hit division at the same time, right? And multiplication and division are left to right. And then after you finish multiplication and division, the last thing to handle are your additions and subtractions. These are also left to right. Okay, now we can shorten this down a little bit. I like to just use the first letter of each thing, but here's why it's set up the way it is. Okay, when you start asking yourself and you really think about it, why does multiplication come before addition and subtraction? Why? I mean, was it just a bunch of mathematicians sitting around at a bar one night going, I think this will confuse them. Let's do it this way. It wasn't something like that. It wasn't nearly as nefarious as all of that. When you look at a problem, let's suppose I was looking at 3 plus 4 times 5. Okay, now if you're working it out this way, it doesn't lend itself to showing you why. But remember, 4 times 5 is adding 5 4 different times. So what this actually means is 3 plus 5 plus 5 plus 5 plus 5. Right? Now, if you were going to add all this up, the quick way to do it would be to turn this part into multiplication, do it first, do this part first, and then add your 3 back in. And the reason that multiplication comes first is because it's actually grouped addition, right? You're taking care of a whole bunch of additions at once, then you do all the detail addition. Same thing happens when it comes to exponents and multiplication, right? If I look at something like this, 5 times 3 to the 4th, right? This is 5 times 3 times 3 times 3 times 3. Now, if you're going to do it multiplication, you could go 5 times 3 is 15 and just keep multiplying the 3's as you go across. Or if you have a nice way to group it, you could look at this all at once first, get an answer for this, and then multiply that answer by 5. Right? And so multiplication comes before addition because multiplication is repeated addition. Exponents come before multiplication because exponents tell us about repeated multiplication. And then the other thing, where does division and multiplication fit in here? Well, division is the same thing as multiplication, right? We have, if I look at something like, 5 divided by 10 times 2. Now, the common misconception is that multiplication always has to go first. And it kind of feels like it's grouped together here. But if you go back and actually look what that division by 10 means, what it actually means is 5 times 1/10 times 2. And you notice it's all multiplication now. So that means the division and the multiplication are actually the same operation. You can rewrite them that way. And so that's why we compute these things left to right. If you're going to do this, 5 divided by 10 is going to be 1/2 times 2 equals 1. Over here, same thing. 5 over 10 gives you 1/2 times 2, and that equals 1 as well. But if you did the multiplication first, right, let's do it here. If you did the multiplication first, you'd have 5 divided by 20, and 5 over 20 is 1/4, right? And so you can see we get completely different answers. There's a big difference between 1 and 1/4. So over here, this is wrong because of the fact that you did multiplication first, right? It's not that division has to come first. It's whichever one is farther to the left comes first. Okay, and then it ends up being the exact same thing with addition and subtraction. There we go. All right, and just clean up the last of that. If I have something like 5 minus 3 plus 6, there's no reason 3 plus 6 has to come first. In fact, it can't in this case. It can only come first if you rewrite everything in terms of addition. So that means that you can rewrite the subtraction as plus -3 plus 6. Now it's all addition again, right? So that's why addition and subtraction are actually the same thing. You can always rewrite one as the other. All right, so what I want to do now is I want to start taking a look at some examples. And that's pretty much what we're going to be doing from here on, is just seeing how those order of operation rules apply. Why is this not erasing? There we go. Okay, so let's go ahead and rewrite this here. So we have, oh, it works better with the writing tool on. We have parentheses, exponents, multiplication and division. I go out of my way to write those on the same line so I don't forget that it doesn't matter which way they go. And then addition and subtraction. Okay, now so let's look at our problems here. Now I'm going to write these 3 problems down. There's going to be 3 of them this time. And what we're going to do is, well, I want you to pause the video once I get these written down. I'll tell you where to pause. See if you can work them out on your own, and then continue to play the video so that you can see if you did it correctly, right? All right, so here are the problems that you're going to be working on. So these first ones are pretty straightforward here. So we got 7 minus 12 plus 4, 7 divided by 12 times 4, and 4 times 5 squared. Okay, so those are your 3 problems to work on. So go ahead and pause here. All right, so now let's take a look here. If you're playing this, I'm assuming that, well, you're ready for the answer anyhow. So coming over here, let's see, we have all addition and subtraction. And I know that they go in the order that they're listed in the problem. And since the subtraction is farthest to the left, I'm going to start there. 7 minus 12 is -5. And then I still have this plus 4 here. And so I need to add -5 plus 4. And if I add those two together, I get -1. Okay, so that's my answer for the first one here. Now, second one. If you multiply the 12 and the 4 first, that's the wrong direction to go. You won't have the correct answer. But the first operation here, because division and multiplication are the same thing, the first operation that shows up is going to be the first one you do. So 7 divided by 12. Now we just finished talking about fractions. It is, instead of doing the the entire division, it's a lot easier to just leave it as a fraction. And then we're going to multiply that by 4. And if I'm going to multiply by a whole number, remember that what you do is you write that whole number over 1 so that you can use the cross-canceling trick that we did before. So 4 goes into 12. That'll give me a 1. That'll give me a 3. And if I multiply everything else out here, I got 7 times 1 is 7. 3 times 1 is 3. And so we get 7/3. If you actually did the division, you end up with a repeating decimal. So this is actually a little nicer way to go. Fractions are your friends. I know people are terrified of fractions, but they really make your life so much easier. You don't end up with infinite decimals. All the operations are pretty nice to do by hand, and I know people are afraid of them, but they're really, really useful, and we will be using plenty of them because I am not bashful about fractions. Okay, so last of our first examples here, we have 4 times 5 squared. Now we have 2 different levels of operations. We have the multiplication level, and then we have the exponent level. And so exponents come before multiplication and division, so that means I'm going to square this 5 first. So that means I have 4 times 25 now. Now, if I multiply these two, I get 100, which is, I know that's going to be what everyone gets on their first test. It's going to be great. All right, so there is the first set of stuff. Now, let's go ahead and take a look at the next set here. Let me go ahead and clear this off. Oops, that is not what I meant to do. There we go. Oop, wrong way. Let's try this again. Where was I? Somewhere around there. All right. Okay. Okay, so for our next round, I got 2 of them here, or 3 of them, excuse me. Let's do this. Oh, I'm still on eraser. There we go. Let's look at 2 times 3 squared, 2 times 3 squared, and 2 plus 3 squared. Okay, so they're all a little different. They all have the same numbers in them, but they're organized a little bit differently. So again, just to test to see what you know, pause the video here and then see if you can work on them. Okay, so you're back. Let's go ahead and take a look here. So this first one is very similar to what do you call it? To the last problem we were doing. So we know we have to square this first, which will give me 2 times 9, and then 2 times 9 is 18. So the answer to the first problem is 18, right? 2 times 3 squared. Now, here, the whole thing is being squared, right? The 2 squared and the 3 is squared. So it's that entire quantity. If I look at this, I have operations in parentheses. So you want to handle the operations in the parentheses before you handle anything outside of the parentheses. So 2 times 3 is 6. So this makes that 6 squared. And then if I square 6, I get 36. And so that's the answer I get for that one. Okay, so if I look at this third one here, it's pretty similar to this last one, but the difference is instead of multiplication in here, I have addition in here. And so we do have to do the addition first. And 2 plus 3 is 5. And if I square this here 5, I get 25. Now, you notice I put parentheses on here. I could have just as easily written 6 squared. The reason I do that is because it's a good habit to get into of just using those parentheses whether you need them or not. Because what happens sometimes are things like this. let's go ahead and just look at another problem here. Um, if I have something like um, negative 5 plus 2 squared, if I add these together, I get a negative 3. Now, here you do need the parentheses, right? The square of negative 3 is 9. If you leave the parentheses off and write this, what that means is you'll get an answer of negative 9. You can even try this with a scientific calculator and it will do that. Here's why. If the negative is in the parentheses when I square it, that means it's negative 3 times negative 3, right? And a negative times a negative does give you a positive. However, if that negative is not in the parentheses, then the only thing being squared is the 3. And what this is actually saying is this. It's the negative of 3 squared. Right? And so you do get very different answers. This one gives you positive 9. This one gives you negative 9. And you need to know that if you're going to be using your calculator to calculate some of this stuff. Because if you have to square a negative and you leave the parentheses off, you will get the wrong answer. So you got to be real careful on that. That's actually a very common misconception because it doesn't happen that often. So it happens most of the time you get the right answer. But if you don't, it's usually because you forgot some parentheses somewhere. All right, so let's go ahead and clear this off and we'll look at the last couple examples here. There we go. And yeah, got that. Okay, so our last couple examples here. Oh, that's not the one I wanted. Let's see here. Okay, here we go. 4 plus 9 times 8 minus 2 minus 2 cubed. All right. Okay, so when we take a look at something like this, we just start walking down the line here. We start with parentheses. Are there any operations in parentheses? Well, the answer is yes. I have 8 minus 2 here. 8 minus 2 is 6. And so I'm going to color code this. Everything I change, I'm actually just going to change the color of so we can see what the last step was. All the other pieces stay exactly the same. So now we still have parentheses, but in this case, these parentheses indicate multiplication now. So the next thing that we need to handle, since there aren't any more parentheses, are the exponents. And there's one exponent. Oh, I changed the exponent on that. That's a 3. There we go. There's one exponent to handle. Now notice this has a negative. There's no parentheses. So that means we're just going to cube this directly. So that's just going to be an 8. And then everybody else comes down exactly the same as you have it. Okay, so now, let me make sure that looks subtractive. Now we look at it and we say, okay, we've taken care of all the parentheses, all the exponents. We're on to multiplication and division. And so if I have more than one of these, I'm just going to move across left to right. 9 times 6 is 54. So this is 4 plus 54 minus 8. 4 plus 54 is 58. Notice we have a multiplication, or an addition and a subtraction. So we're just moving left to right this time. This time the addition comes first. Oops. There we go. Minus 8. And then we only have one operation left. 58 minus 8 is 50. Right? So there was a lot more steps to that. But notice something here. When we looked at the very first step here, we only had to do one operation. Once we did that operation, you can almost just kind of write off this step and pretend like it's not there, and then look at the next step like it's a brand new problem and you're starting it. And from here, you would decide, oh, if this was a new problem, I'd be doing the exponents first. And so you do that. And then this one's gone, and now this is your new problem. And so you're just walking through the first step a bunch of times. And as long as you hug the order of operations tightly, you'll get the correct answer at the bottom every single time. Okay, so that was a little more complicated example, but you can see how we're moving through it. No one step is super complicated. It's just knowing what the next step is. And the other thing I want to warn you about too is this may be for some of you the first time you don't see the entire process of how to do it when you first look at the problem. That's okay. As long as you know what the next step is, you have something you can do to get closer to the answer. And so that's what you're doing. You're just gradually getting closer and closer to the answer until you're only one step away, and then you take the last step. Okay, so let's clear that off, and then we'll look at our last example here. Let's get this out of here. All right. So our last example now is going to be let's put it in black. 2 times 5 squared minus 2 squared plus 5 divided by 2 times 5 minus 2 squared minus 11. Okay, so the strategy I always take when I walk through these is to do, well, it's just to consider this two different problems. I have something to simplify on the numerator, and I have something to simplify in the denominator. I can take one step in a numerator and a denominator at the same time. So I actually walk through these, both the numerator and the denominator simultaneously. So we'll do one step on each as we go through here. So parentheses. In the numerator, I have no parentheses. Exponents. Okay, I do have exponents, and they don't have any other operations inside of them. So that means I can compute both of my exponents here. So that means that I have 2 times, and now that is 5 squared is 25, minus 2 squared is 4. Oops. So I'm actually changing two things this time. And then plus 5. Down here, let's see, I have an operation inside of the parentheses. So that means I have 2 times 5 minus 2 is 3 squared minus 11. Okay, so we've taken a first step with each, the numerator and the denominator. And so now we'll just walk on to the next step. So in the numerator, I have parentheses, but there's no operations inside them. So this just means multiplication. So that means I can go 2 times 25 is 50. And that's minus 4 plus 5. And then over here, I have 2 times, well, 3 squared is 9. Let's see here. And that's minus 11. Okay. Right, so now I have this. And now I can just go through and simplify the rest of this. We'll do a subtraction, then addition here, because it's always left to right. 50 minus 4 is going to be 46 plus 5. 2 times 9 is 18 minus 11, right? Okay, and then for our next step, 46 plus 5 is going to be 51. And 18 minus 11, let's see here, 18 minus 10 is 8. So we get 7 out of that. Oops, wrong one. So I get 7 here. And 7 does not fit into 51. 51 is 3 times 17. So that means we're actually done at this point, and this is our answer. Right? So you could very well get a fraction for an answer too, especially when you have fractions in the original problem, or the original problem is a big fraction, or this could simplify down to a whole number. Right? So a lot of things could happen here. The main thing you need to do is just stick to these guys. And then as you do more and more of these, what ends up happening is you start to see places that you can take shortcuts because you start understanding how everything's actually hooked together. So in any case, Let's see here. That concludes our lecture, and so you guys have a good rest of the day and keep your pencils sharp.